Please title these notes Graph 6 Notes, Prerequisite, Sign Charts, and write today's date. By the end of this lesson, you should be able to make a sign chart from an equation. This is a prerequisite skill for being able to do the later lessons, specifically graph analysis based on equations. Basically, we need to be able to tell what values for x make a function positive and negative. And these values are tracked using a sign chart, which is just the plus and minus line of the three-line chart. So let's start with a little how-to create a sign chart. First, factor the expression. If possible, sometimes it's not. And sometimes it's not needed because it's already factored. Find zeros or undefined values. And mark them on the sign chart. Pick one test point. Really, I should say test value. Between each zero and plug it into the equation. To determine if each factor is positive or negative. And then lastly, determine if the overall function is positive or negative in that interval. And mark it on the sign chart. Here are some key facts to know when creating sign charts. Exponential functions, that's e to the x, 2 to the x, etc., are always positive. Logarithmic functions, so that's ln x log base 3 to the x, etc., have the following pattern. Undefined when x is less than or equal to 0. Negative when x is between 0 and 1. 0 when x exactly equals 1. Positive when x is greater than 1. Also, just be aware, as x gets bigger, the exponential function gets bigger too. So, for example, the natural log of 5 is going to be bigger than the natural log of 3. Okay, anything positive or negative, well, except for 0, raised to an even power, so that's x squared, x to the 4th, x to the 6th, etc., is positive. There are some rules involving square roots. Square root of a positive is positive. Square root of 0 is 0. Square root of a negative is undefined. However, for cubed roots, cubed root of a positive is positive. Cubed root of 0 is 0. Cubed root of a negative, still negative. This holds true for all odd roots. This holds true for all even roots. Other random factoids. If the denominator of a function is 0, so for example, 1 over 0, f of x is undefined if the numerator is 0, so like 0 over 1, f of x equals 0. Finally, absolute value of x is always positive. So we're going to use these rules to create some sign charts. So our first problem, these are examples. Create a sign chart. So this just means record positives and negatives for f of x equals x squared plus 3x plus 2. So the first step on our previous page is factor the expression. If we can indeed. So this is x plus 2, x plus 1. Now what we're going to do is we're going to find the zeros. So remember that anything times 0 is 0. So if this whole factor equals 0 or this whole factor equals 0, then the whole thing equals 0. So there are two zeros. And now we want to mark them on the sign chart. Make sure you do them from left to right, just as if it were a number line. And now it says to pick one test value between each zero, so that actually includes over here between this 0 and negative infinity as well. And we are going to just pick a number, so let's call this over here, let's say this is -3. Let's pick the number -3. And we're just going to plug it in, make sure you use the factored form. We just need to figure out overall positives and negatives. So using the original f of x equation, this is going to be -3 plus 2, -3 plus 1. We could have used any number less than -2, so -1,000,000 if we wanted. But we don't have to actually go and multiply and add all this out in order to figure out if this overall number is going to be a positive or a negative. All we have to do is figure out plus and minus. So -3 plus 2, we know that's going to be negative, and -3 plus 1 is also going to be negative. So a negative times a negative, that gives us a positive overall. All we really need to know here are the negatives and the positives. So here, let's pick a number in between 0 and -1. Or excuse me, between -2 and -1. So really the main number that's in there is -1.5. So let's come on over here, let's try to figure out f of -1.5. So that's -1.5 plus 2, -1.5 plus 1. We can see that this -1.5 plus 2 is going to be a positive number. -1.5 plus 1 is going to be a negative number. So negative times positive negative overall. Our final one over here, we just need any number bigger than -1, so 0 is a perfectly good number. Zero plus 2 is a positive, 0 plus 1 is a positive as well. Positive times positive is a positive. And there's our sign chart. This right up here, the top positives and negatives, and then the numbers for the zeros, that's the actual answer. What we're doing down here is we're showing work. There are shorter ways to show work. That's totally fine. If you just have the positives, negatives marked down here, that's perfectly acceptable for showing work. So let's do another one. Create a sign chart for f of x equals 6x squared plus 24x. So rather than doing our diamond or our box to factor up here, we've got common factors. So 6 and x are in both of them, so 6x can be factored out. And we've got x plus 4. So now we find our zeros. 6x equals 0, x equals 0, x plus 4 equals 0, x equals -4. And we mark those on our sign chart. So now we just pick a number smaller than -4. So let's say -5. So we've got 6 times -5, -5 plus 4. So this is a positive, this is a negative, this is a negative. Negative times a negative is a positive. Between -4 and 0, let's call that -1. You could have picked -2, -3, any number between -4 and 0. So we've got 6, -1, -1 plus 4, positive, negative, positive, negative overall. Any number bigger than 0, let's say 1. So that's 6 times 1, 1 plus 4. They're all positive. Right like that. By coincidence, they happen to end up being the same pattern up here, but that's simply coincidence. And now one of the things you might wonder is why can we just take these negative and positive patterns and say that this is positive for the entire interval? Well, the deal is that we found where x equals 0, or excuse me, where f of x equals 0 by finding these zeros over here. And because we have a continuous function, the only way we can get from a positive number for f of x to a negative number for f of x is to go through 0. This is the intermediate value theorem. And so if we know that the only zeros are here and here, and we know there's a positive number over here, then f of x has to be positive for all of these numbers until it passes through a 0 to get to potentially being negative numbers. Okay, for our next one, let's create a sign chart for g of x equals x plus 3 over x minus 5. Now the key thing here is that we are interested both in zeros and in undefined values. So we're interested in x plus 3 equals 0 or in x minus 5 equals 0. Because where there's an undefined value, it's also possible to have f of x switch from positive to negative. So mark that on our sign chart, -3 and 5. A number less than -3, so -4 plus 3 over -4 minus 5. That's going to be a negative divided by a negative. Negative divided by a negative, still positive. Between -3 and 5, 0 is a good one to use there. So we've got 0 plus 3 over 0 minus 5. So that's a positive and a negative. Negative overall. number bigger than 5, so 6 plus 3 over 6 minus 5. That's a positive, that's a positive, positive overall. So this is the same idea for all the rest of the problems. We're just going to be looking at problems that have trickier and trickier pieces to them. So let's create a sign chart. For h of x equals negative 3x times x plus 4 squared. So we can treat this negative 3 and x separately, or we can just do them as one factor. It really doesn't matter. Negative 3, x equals 0, x equals 0, x plus 4 equals 0, x equals negative 4. Now, we pick a number less than negative 4, so negative 5. So we've got negative 3, negative 5, negative 5 plus 4 squared. One of the key things to notice here, anything squared, remember, is positive. So regardless of what number we put in here, we actually don't even need to put a number in there. That's always going to be positive. We've got a negative and a negative. Negative times negative is a positive. So a number between negative 4 and 0, let's say negative 1. So we've got negative 3 times negative 1. And then this, I don't care what it is, actually. I'm not even going to bother to put the number in. That's squared, it's got to be positive. Same pattern. A number bigger than 0. So we've got that negative 3, multiply by 1, something squared, we don't care what it is. Negative, positive, positive. Okay, now let's start tossing in some transcendental functions. That's like sine and ln and all that kind of thing. Create a sign chart for j of x equals the natural log of x times x plus 2 cubed times e to the x. So now this is where you really need to have memorized the information that I gave you the key facts to know over here. Logarithmic functions, here's where we're talking about the zeros and the negatives and the positives. Exponential functions are always positive. They can actually never equal 0. So natural log of x, we can also solve this out by doing e to the power of x equals something to the 0 power, that's 1. X plus 2 equals 0, x equals negative 2. And then e to the x equals 0, well, that never happens. So I'm just going to write a little x there. Doesn't happen. Okay, so now let's go ahead and make our little sign chart. So we've got a negative 2. We've got a 1. Whoops, that's not a 1. Okay, so now we're going to go along. We're going to go ahead and pick a number less than negative 2. So let's do natural log of negative 3, x minus 3, whoops, negative 3 plus 2, so that should be going off right there, cubed e to the negative 3rd power. Now, the first thing to notice here is that when we go to evaluate this natural log of negative 3, this is undefined. Negative numbers not in the domain of the natural log. We can't do that. So actually, before we go any further, we should cross off all the numbers that are less than 0. Let's do this in purple. So this is at 0. We actually can't make a sign chart for this half because if we plug in any number 0 or smaller, we can't get any numbers out at all. So that means that what we're actually going to be working with is just this little part over here. So we're going to be working now between 0 and 1, so that's 0.5. So natural log of 0.5, 0.5 plus 2 cubed, e to the 0.5. Remember, if this number is between 0 and 1, natural log is negative. This is positive, a positive cubed is positive, and e to the whatever is always positive. So that's negative overall. This one over here, let's pick a number bigger than 1. So 2. So natural log of 2. 2 plus 2 cubed, e squared. If x is greater than 1, then the logarithmic function is positive. Positive cubed is positive, and e to the whatever is always positive. So there's our sign chart. We just have to be careful with the little natural log if we see them show up. We're going to do one more problem together and then a check for understanding problem. So here there's nothing to factor. We want to find both zeros and undefined points. So add natural log of x to both sides. Do e to the power of. And remember, e is just a number. It just stands for about 2.78. X minus 5 equals 0, x equals 5. So let's put the approximation for e under here. Excuse me, that's 2.718 right there. So when we draw our sign chart, e is going to go here. 5 is going to go there. Think of this as going approximately where the 3 is. So we're dealing with natural log of x again. So we know that the domain, again, we can't put in any number 0 or smaller for this. So before we do anything else, I'm going to cut this off at x equals 0. I think ln x is the only time that you're really going to have to worry about that crossing off part of it. But make sure whenever you see this that you do that right off the bat. So we need a number between 0 and e, so 1 will be just fine. 1 minus the natural log of 1. That's particularly convenient because we know exactly what the value is of natural log of 1. So this is going to be 1 minus natural log of is 0 over 1 minus 5. So this is going to be a positive, that's going to be a negative. We have a negative overall. For this part in the middle, we're looking at some number bigger than 2.7 but smaller than 5. So let's just play it safe. Let's go for 4 here. So 1 minus the natural log of 4 over 4 minus 5. A natural log of a number greater than 1 is positive. But the thing is that it's a little tricky to figure out exactly, is this positive number going to be bigger or smaller than 1? Because that makes a difference in terms of if this is positive or negative. So we've got a little separate question over here. Is the natural log of 4 bigger than 1? Well, let's see. What numbers can we find the exact value of? Well, we know that natural log of e, that's log base e of e, This is e to the first power. So these would just cancel right out, and that would be 1. We also know that as x gets bigger, natural log of x gets bigger. So because 4 is bigger than e, because remember e is about 2.7, natural log of 4 is bigger than 1. So the answer to this is yes. And that means over here we have 1 minus a number bigger than 1. 4 minus 5. So 1 minus a number bigger than 1, that's a negative. 4 minus 5, that's also a negative. And for the final piece de resistance, let's say we've got a number, let's call it 6. Right there. 6 minus 5 is going to be a positive number. We know that natural log of 6 is going to be even bigger than natural log of 4, which is even bigger than natural log of e, which is 1. So that means natural log of 6 is also a number bigger than 1. 1 minus a number bigger than 1 is negative. Negative times positive is a negative, and there we go. That one's a little trickier than most that we see on the AP test, but there is actually a problem that requires just this logic on one of the released test questions. So it's good stuff to be able to do. If you're confused about the overall ideas, make sure that you're able to do these other problems, 1 through 5 first. Should be super solid on those, and then push yourself to be able to do that one. Okay, let's do our final check for understanding problem. Make a sign chart for j of x, which equals x, e to the x, x plus 3, x minus 4 squared. Pause the video and do that one on your own, then restart the video when you're ready. Okay, x equals 0, e to the x equals 0, which never happens. X plus 3 equals 0, so x equals negative 3. X minus 4 equals 0, so x equals 4. Give ourselves lots of room. Negative 3, 0, and 4. So pick a number less than negative 3, so call it negative 4. E to the whatever, we really don't care because it's always going to be positive. Negative 4 plus 3. Negative 4 minus 4 squared, although this is squared, so it's always going to be positive. We don't care what it is. That's negative, that's always positive. That's negative, a negative times a negative is a positive. Between negative 3 and 0, so let's say negative 1. E to the negative 1 is always positive. Negative 1 plus 3. And then something squared, which is always positive. So negative 1 is negative. Negative 1 plus 3 is positive. We've got a negative overall. Between 0 and 4, let's say 1. So we've got 1. E to the first power. 1 plus 3. And something squared. All positives. And then let's say the number 5. Got 5. E to the 5th. 5 plus 3. And something squared. Also always positive. That concludes these notes.